Hello everyone and welcome back to the channel. Today we're going to be kind of learning more about these boost converters. Now I have a 12 volt to 24 volt 10 amp max boost converter right here, and I went ahead and put a couple of XT60 connections on there to make it easier. And I really wanted to find out what exactly does this do. So let's get started. So when I first bought this, I always thought that all it did was take your 12 volt source and multiply the voltage by 2, and it would divide the amperage by 2, basically converting it, and it would keep the same wattage. So for example, if you had a 12 volt 10 amp source, this would take it up to 24 volts and output 5 amps. And that just made sense to me. So logically, if you had a 13 volt 5 amp source, this would boost it up to 26 volts and drop it down to 5 amps, thus still keeping the same wattage. Well, I really wanted to put that to the test, so I've got a little bit of test equipment back here, and we're going to go ahead and hook this up and see exactly what it does. Okay, first of all, let me show you how you would hook this up. On the back of the boost converter, it does show an input 12 volts plus and minus, and an output 24 volts at 10 amps minus and plus. So all you would do is take your positive and negative of your 12 volt source. Now in this example, this is going to be my 12 volt source right here. So I'm going to go ahead and hook up this XT60 connector, and what it's doing is it's just going to a couple of ferrule plugs. And I'm going to take my positive of my 12 volt source and connect it to there, and my negative of my 12 volt source connected to there. So now my 12 volt side is all connected, and then the 24 volt source is going to my power draw right here. So I'm just going to go ahead and connect these up, and there we go. So we have my 12 volt source going in to here, and it goes through the converter, and it comes out this way, and it goes to my 24 volt power draw. So I hope that makes sense. All right, so the first thing we're going to do is we're just going to do your typical 12 volt source and see what happens on the 24 volt side. So I'm going to go ahead and crank up our amperage all the way, and I have this set for a constant voltage of 12 volts. And you can see over on this side, it is not exactly double, but it is 24.2 volts on this side. So as we draw some power to it, let's just draw a couple of amps, about 2.1 amps. You can see that the voltage stays at 12.01, and the voltage over here stays at 24. So it's doing exactly what you expected it to do. The amperage is 4.8 over here, and it's only pretty much 2.1 over here. And let's just go ahead and boost this up to a 14 volt draw. Okay, we're now looking at 14 volts for a draw, and so we would think on this side it would be 28 volts, but it's not. It's still 24.1 volts. We still have about a 51 watt draw over here and a 57 watt draw over here because of the wiring and conversion losses. But you can see it didn't double the voltage. It regulates it. So this is actually like a boost regulator. It will keep your voltage at 24 volts in a wide range of voltages on the 12 volt side. Let's see how low we can go before this number starts to fluctuate. So let's just say we had it at 12. At 12 volts, you can still see that it's 24.1. But what's happened is the amperage has gone up, and this is still at 2.1 amps. So it's regulating everything on the 24 volt side. Let's go ahead and lower it down to 10 volts and see what happens. All right, we now have 10 volts. The amperage has gone way up because, again, this boost converter is regulating the output. So it's increasing the amperage when the voltage lowers in order to keep this 24.1 volt at 2.1 amps. I found that very interesting. I always thought that it would just double the voltage and cut the amperage in half, but it doesn't. It actually regulates it. So let's keep on going down and see what happens. Let's go down to 9 volts. All right, we're now at 9 volts and it's 6.78 amps. So we're drawing, it's pushing out about 61 watts. And again, the voltage is 24.1 and the amps are 2.1 amps. So we're getting about 50.5 watts. So the conversion is getting worse because the amps are, this wiring is probably starting to hinder the amount of amps that it can actually receive. So let's go ahead and go down to like 8 volts. See, now 8 volts, we're starting to kind of push this unit because it can only do 10 amps. So we're right at around 8 volts, but you can see that the boost converter is starting to have trouble. It's actually lowered down to 23.9 volts at 2.9 amps. So the regulation of it all is starting to kind of slip. So if you go even lower than that, like 7 volts, yeah, this starts freaking out and the regulator can no longer keep up. So what it does is it drops it down, it dropped it down to 6.48. So basically the boost part of the boost converter has stopped working. So what happens if we go back up to 8 volts? Again, it's not really working that well. Let's go up to 10 volts. And now, as you can see, at 10 volts, it's back up to 24.1 and 2.9. So once the voltage gets too far down, if the amperage can't keep up, the boost converter shuts the boost part of it off, and it just kind of lets the electricity flow through. But let's see what happens if we start increasing it. So let's go like 14 volts, which we already did, but just wanted to show you. So 14 volts at 4 amps, 24.1, 2.1. So this is staying regulated. Let's go up to 16 volts. Okay, now we got 16 volts. Again, this is staying at 24.1 and 2.1. So this is still, the boost converter is still pushing out 24 volts at 2 amps, regardless of the voltage on this side when it gets higher than 12 volts. Let's go up to like 18 volts and see what happens. Okay, now we're at 18 volts. It's pushing out 3 amps. And our voltage on the out port is now starting to fluctuate a little bit because again, the converter is starting to have an issue converting 18 to 24. So let's go ahead and go up to like 20 volts. See what happens. Yeah, and you can see that we are now almost at 19, we're at 19.5 volts and the converter has basically stopped and it is down to 19 volts. So after probably at 19 volts, the converter again stops boosting and just lets the voltage flow straight through. But once you lower it down to 15.8, it jumps back up to 24.1. And I just find that very interesting. Now, I know this video isn't going to answer every single question that you have about these boost converters, but it answered the big one that I had, and that was, does it multiply the voltage by 2 and divide the amperage by 2? No, it actually regulates the output. It'll actually take a range between what looks like 9 volts all the way up to like 16 volts, and it will boost it up to a 24 volt regulated output with a 10 amp max is what this variety has. So this actually has a lot more range than what I ever thought it did. So if you have any questions, please go ahead and leave them in the comments. I'll have a link to this item in my description if you want to look further into it. Thank you so much and have a great day. Bye-bye.